In the last sessions, we covered already. There are several operators we discussed, sir. Have you remembered? We covered arithmetic operators. Yes, man. Have you remembered, right? We covered arithmetic operators. Next, after arithmetic operators, string concatenation operator, string repetition operator, we covered star, relational operators, we discussed, sir. Equality operators, logical operators, we covered. Okay, like now, bitwise operators we are going to discuss. Sir, why the word bitwise? Anyone, can you please tell? The word bitwise. Why the word bitwise? Why the word bitwise? Bitwise. Bit by bit. Are you getting why the word bitwise? Bit by bit. We are going to operate the operations bit by bit. These things are by default considered as bitwise operators, right? These operators are applicable. Okay. So where we can apply? That part we are going to talk. It is always going to apply bit by bit. That's why the operators are by default considered as bitwise operators, right? Okay. Remember. Next one small. Sir, bitwise operators we are discussing. Sir, now why the word bitwise? Why the word bitwise? Bitwise operators, right? Because we are performing bitwise. Bitwise. We are performing operation bitwise. That's why it is considered as bitwise operators, right? But make sure, very important point, sir. Sir, we can apply these operators only for int and boolean. Only for int and boolean. You can't apply for string. In the case of string values you never going to represent in the form of bits. Next, and after that you never going to use float. For float also not possible, sir. You can apply these operators only for int and boolean. Okay, by mistake if you are trying to use for any other type, immediately we are going to get error, sir. Remember that, sir. Which operators are bitwise operators? And next, and after that r, next and r, next xr operator, cap symbol is xr operator. Next, and after that bitwise complement operator, next left shift comma right shift operator, right? These things are bitwise operators, right? And r, xr, next bitwise complement, left shift and the right shift operators, right? Okay, make sure, sir, you people should aware clearly, right? Sir, now it is applicable only for int and boolean. By mistake if you are trying to apply for any other, immediately you are going to get the error, sir. Sir, best example if you consider that, best sorry, best example if you consider that, here just py, just I'm taking here, just my requirement is, sir, 4 and 5, 4 and 5, can you please tell, is it valid or not? 4 and 5, is it valid or not? Please guide. 4 and 5 valid or not? Valid, because for numbers happily we can apply bitwise operators, right? No problem at all, sir. Bitwise 4 is the answer. Forget about answer, how it is going to get, I will explain. Next, sir, 4.5 under 10.3, is it valid or invalid? 4.5 under 10.3, is it valid or invalid? Invalid. Just now I told, oh, bitwise operators applicable only for int and boolean. By mistake if you are trying to apply anywhere, immediately error by default we are going to get unsupported operand types, float and float. Are you getting unsupported operand types, float and float? Like this we are getting, sir. So next, true and true I'm taking. True and true, yes, perfectly valid. True is the answer, perfectly valid, because you can apply these operators for int values, you can apply these operators for boolean also, no problem at all, sir. But how the functionality, that part we are going to discuss in detail. Don't worry much about that. Any doubt? Okay, that's all. This is just where you can apply. Now when and operator, how the functionality of these and operators are very simple, sir. If both bits are 1, then only result is 1. Remember, and if both bits are 1, then only result is 1. Sir, R operator. If at least one bit, if at least one bit is one, then result is one. Then result is one. Bitwise. Okay, like that. Can you please tell when XR returns one? If XR returns one, anyone can you please tell? If XR returns one, sir, it is called the if bits are different. XR means what? Exclusive R. If bits are different, 1 0 0 1, like that. If bits are different, then only result is one. Sir, you are telling, okay, what it means? Yes, what it means? You are telling what it means, right? Sir, and okay, R XR. What is the meaning of this one? Okay, like very simple, sir. Sir, if I can take 4 and 5. Observe very carefully, sir, how the bitwise operators are going to work. 4 and 5, how it is going to work, sir? Here, now observe 4. 4 means what? 1 0 0. 4 means what? 1 0 0. 5 means what? 1 0 1. Like this, right? 5 means what? 1 0 1. 1 0 1. Sir, 0 0 1 AND operator we are using when AND operator returns 1 if both are 1. But here, first one is the 0. That's why, sir, 0 by default you will get. Sir, have you observed? Bitwise, we have to apply. First, I'm applying these 2 bits. Next, I have to apply these 2 bits. AND operator, right? 0 0. Next, 1 and 1. Oh, both are 1. That's why 1. So 1 0 0. What is the answer? By default, we are going to get, sir, 4 is the answer. Are you getting? 4 itself is the answer, sir. Remember, 4 and 5. The answer is always 4. What is the meaning of bitwise? Similarly, 4 or 5. Anyone, can you please guess what is the answer? Please guess. What is the answer we are going to get? Yes, man. 4 or 5. What is the answer by default you are going to get now? 5. 5 itself is the answer. Yes, simple. You can apply bitwise. You can apply bitwise. 4 means 1 0 0. 5 means 1 0 1. 5 means 1 0 1. 1 0 1 like. Sir, 0 or 1 1. 0 or 0 0. Next, 1 or 1 1. 1 0 1 means 5 is the answer. Remember, 1 0 1 itself is the 5. Similarly, 4 XR 5. 4 XR 5. Anyone, can you please tell the answer now? Yes, simple answer. If both the bits are same, then the result is 0. If both the bits are different, then the result is 1. Now observe 4 XR 5. 4 XR 5. What the answers are? 4 means 1 0 0. 4 means 1 0 0. 5 means 1 0 1. 1 0 1. Apply bitwise. Hey, apply bitwise. 0 1. Both are different. 1. Sir, 0 0. Both are same. 0. 1 1. Both are same. 0. Observe that. What is the meaning of XR? If bits are different, if both bits are different, then only result is 1. If both bits are different, then only 1. If both bits are same, then we have to consider 0 0. So 0 0 1. What about its values are? 1 is the answer. Everyone can able to understand, right? How the bitwise operators are going to work. 4 and 5, 4 or 5, 4 XR 5. Now, can you please cross check, sir? 4 and 5. 4 and 5. Yes, 4 is the answer. You know, right? 4 and 5. 4 is the answer. And operator, right? 4 means 1 0 0. 5 means 1 0 1. 1 0 1. And operator, 0 and 1. 0. 0 and 0. 0. 1 and 1. 1 is the answer. 1 0 0 means 4 itself is the answer. Okay. Similarly, 4 or 5. 4 or 5. Sir, what is the answer, sir? 4 means 1 0 0. 5 means 1 0 1. 5 means 1 0 1. R operator, 0 or 1 1. 0 or 0 0. 1 or 1 1. 1 0 1 is nothing, and 5 itself is the answer. Now observe, 5 is the answer. Next, 4 XR 5 I'm taking. 4 XR 5. How it is going to work, sir? 4 means 1 0 0. 5 means 1 0 1. Are you getting? If both bits are different, 1, both bits are same, that's why 0. Both bits are same, that's why 0 is the answer. So 0 0 1 itself is nothing but 1 is the answer. Can you please observe? 1 is the answer. Any doubt? Yes. Any doubt? I repeated second time also, so that you people definitely can feel more comfortable. Are you getting? These things are by default considered, yeah, bitwise operators, right? Okay, sir. Next, one more thing you should aware. Sir, what is the next one? Do you know bitwise complement operator? Bitwise complement operator, right? Bitwise complement operator like you should aware this one. Sir, what is the meaning of bitwise complement operator? Sir, it is not Boolean complement operator. Bitwise complement operators, right? Saravanan, if you are going to develop mathematics based applications, then obviously every operator your Python program is required to reflect. Are you getting? I want to develop one mathematics based application. Are you getting? In my college automation system, one student calculator, I want to provide one smart calculator. Then all these operations you require to provide support. Like internally, the functionality, if you press some plus or something, like we have to do that. So bitwise complement operator. Can you please guide what is the answer by default we are going to get? Very dangerous operators are, take very special care. The people who are not that much comfortable with the mathematics, please take a bit special care. If I can take negation of 5, what is the answer? If you can take negation of 5, anyone, can you please tell what the answer? True na? Good. What the answer by default we are going to get? Yes. Sir, 4 and 5, 4 or 5, 4x or 5, you know, negation of 5 I am taking. What the answer by default we are going to get? Sir, this one, a bit dangerous operator. A bit dangerous operator. Take very special care about this one, sir. Maybe somewhere in the next level I may cover what is the output by default you are going to get, what it means. Observe that. Sir, most of the people are going to feel negation of 5 means 101, 101, then automatically negation means complement. 1 will become 0, 0 will become 1, 1 will become 0, then automatically the output by default you are going to get 2. Yeah, the answer, something like some people are going to feel. Yes, the answer what we are going to get is, observe that, sir. The answer what we are going to get is -6 is the answer. Are you getting? -6 is the answer. Some people are telling -6, but now immediately I will ask, can you please tell the logic? How it is going to be -6? Gurva Reddy, Shubham Misra, can you please tell how we are going to get? How we are going to get? Okay, -6 is the answer. Yes. Leftmost bit is 1. Good. Okay, make sure compulsory you people should aware clearly. Maybe somewhere in the next level we may use these things or not, I'm not sure. Maybe somewhere we may. Sir, if you are very much interested, I will discuss internal thing. Otherwise you can ignore. Sir, do you want me to cover internally what thing is happening? Negation of 5 internally, how you are going to get? Do you want me spend some time? Yes, just 5 to 10 minutes. A bit dangerous concept. Listen very carefully, sir. Yes, matter of 5 to 10 minutes, please. Now observe that a bit very carefully. Yes, here just observe. I'm talking about negation of 5. This is about my requirement, right? Negation of 5. Remember, sir. Sir, do you know in any programming language, including Java also, these rules are same, sir. Here, the most significant bit, is a sign bit, sir. The most significant bit is called sign bit. Most significant bit means leftmost bit is called sign bit. Sir, now one bit reserved for sign. So that bit is nothing but most MSB bit. 0 means a positive number. 0 means positive number. 1 means a negative number. Remember that 1 means a negative number, right? 0 means positive number, 1 means a negative number. So the most significant bit is the sign bit. 0 means a positive number, 1 means negative number. Remember that. Positive numbers, positive numbers will be, positive numbers will be represented, positive numbers will be represented directly in the memory, directly in the memory, sir, directly in the memory. Positive numbers will be represented directly in the memory. Negative numbers will be represented, will be represented, will be represented indirectly in the memory, indirectly in the memory. Just observe, if it is a negative number, it is going to represent indirectly in the memory by using 2's complement form, by using 2's complement form, 2's complement form. By using 2's complement form, you can able to do that. Sir, let me repeat again. So the most significant bit acts as sign bit, sir. The most significant bit acts as sign bit. 0 means positive number, 1 means negative number. Positive numbers will be represented in directly in the memory. Negative numbers will be represented in 2's complement form indirectly in the memory by using 2's complement form. So now my question is, how to find 2's complement? Please respond. How to find 2's complement? In our mathematics somewhere you may heard. How to find 2's complement, sir? Anyone, can you please tell? I want to find 2's complement. How you can able to find 2's complement? First 1's complement. First 1's complement. First 1's complement we have to find, and then add 1. Are getting? First find 1's complement and then add 1. 1's complement plus 1 itself is nothing but 2's complement. I hope you aware. 1's complement plus 1 itself is nothing but 2's complement, sir. How to find 2's complement is like this. Now the point here is, take very special care about this terminology, right? First find 1's complement and then add 1, then automatically it will become 2's complement, right? Sir, how to find 1's complement? How to find 1's complement? 1's complement, sir, most of the people already aware. How to find 1's complement? 0 and 1 interchange. 0 and 1 interchange. 0 replaced with 1, 1 replaced with 0. Reverse the bits, invert the bits, automatically it will become 1's complement. Up to this, your mathematics knowledge, I hope everyone can aware these words. Sir, maybe 1 or 2 points may be new, but 1's complement, 2's complement, from our childhood onwards already we are this. We know these concepts. Correct? Any doubt? Any doubt up to this? Any doubt up to this? Because this one I want to convert into, sir, example. Then all these words are very important. Can you please tell what is the most significant bit? Anyone, can you please tell what is the most significant bit? The most significant bit acts as, what is the most significant bit? The most significant bit acts as sign bit. Acts as a sign bit. 0 means positive number, 1 means negative number. Next, positive numbers will be represented directly in the memory. Negative numbers will be represented indirectly in the memory by using 2's complement form. Clear? Next, sir, 2's complement, how you can find? 1's complement plus 1. How to find 1's complement, sir? Just interchange zeros and 1's. That's it. Okay? If you feel comfortable, now come back to our regular story. Sir, I want to find negation of 5. Remember this one. I want to find negation of 5. This is about my requirement, right? Sir, first question. How to represent 5 first? How we can represent 5? This is the very important first. Represent 5 in the memory. It is a very important, sir. Yes, here most of the people, common mistake is they are going to do is, sir, they are considering only 3 bits. They are considering only 3 bits, 4 bits and so on. Remember that. So it is internally something like 32 bits, 64 bits, some convention is there, sir. Default in any programming language, most of the times int value means 4 bytes. 4 bytes means how much space, right? 4 bytes means how much space, right? 32 bits. 32 bits is going to be considered 32 bits. In that 32 bits, the most significant bit is the sign bit. is the sign bit, right? The most significant bit is the sign bit. Sir, now because it's the positive number, it is the 0. Sign bit is the 0 because 0 means positive number. One bit already reserved for sign. Then how many remaining bits are there? How many remaining bits are there? 31. Sir, now 31 bits represent value directly. It's a positive number. That's why 0 0 0 0 0. Okay, 0 1 0 1. Are you getting 1 0 1? This is 5. Internally, memory level, how you can represent 5 is nothing but 0 0 0 0 0 and so on. At last 1 0 1 is the 5. 1 0 1 means 5. You know, right? Positive number. Clear. Now I want to find the bitwise complement of 5. Are you getting? I want to find the bitwise complement of 5, sir. So bitwise complement of 5 means you have to apply complement operator for 32 bits, not for 3 bits or 4 bits. Remember this one, sir. We have to apply for 32 bits, not for 4 bits and so on. Yes. How you can apply, sir? Complement for 32 bits. Now zeros will replace with 1, ones will replace, because complement, right? Zeros will replace with 1, ones are replaced with 0. 1 1 1 1 1 1 1 0 1 1. Next last 1 0 1 0 1 0. Sir, very simple. Bitwise complement means interchange zeros and ones. Interchange 0 0 will be replaced with 1, 1 will be replaced with 0. Whatever value represented by this one itself is negation of 5. Okay, whatever the value represented by this combination is the negation of 5. Then immediately you may ask, in this, what is the most significant bit? Is it 0 or 1? Array, please respond. What is the most significant bit? Is it 0 or 1? Ayo, is it 0 or 1? 1. 1 means a negative number. 1 means a negative number. Remember that, sir. It is a 1. 1 means a negative number. Sir, if it is a negative number, then the remaining bits won't represent value directly. The remaining bits represent value in 2's complement form. Oh, for the remaining bits, we have to apply 2's complement form. Are you getting? Because the most significant bit is 1 means a negative number. 1 means a negative number. Negative number means so then the remaining bits will represent a value in 2's complement form. Sir, first find 2's complement form of this one, then automatically you will get the value. Most significant bit means the first bit, Lakshmi. Clear up to this? Yes. How to find 2's complement form? How you can find 2's complement form for this? First find 1's complement. 1's complement means how you can find. 1's complement means how you can find 0 0 0 0 0 0 0, and then, sir, 0 will become 1, 1 will become 0, and then 0 will become 1. That's all, sir. This is 1's complement. First find 1's complement, and then add 1, and then add 1. Sir, 1 plus 1 0 0, and the end carry 1. 0 plus 1 1, and 1 is here 1, and then remaining bits are all are zeros, right? If all are zeros, what is the value of 0 1 1 0? 1 1 0 means 6, sir. 6 already negative number. That's why the result by default we are going to get minus 6 is the output, sir. Are you getting? At least 50% of the people can able to understand my discussion. Thoda. At least 50% of the people can able to understand my discussion. Yeah, I will do that. Don't worry. First, yeah, I'm repeating again. Observe carefully, sir. Can you please read these statements? Very, very important. So if you want to represent any number, the most significant bit acts as sign bit, sir. The most significant bit is the sign bit. 0 means positive number, 1 means a negative number. Remember this, 1 means a negative number. Sir, this is the integral value. You have to represent this value in the memory binary form. Remember that in terms of zeros and ones. Okay, how to represent first 5? How you can represent first 5? We should aware. If you represent 5, then how you can get negation of 5? This negation of 5 just interchange zeros and ones and zeros like this. Now I will get the negation of 5. Sir, in this, what is the most significant bit? 1. 1 means a negative number. If it is a negative number, the remaining bits represent value in 2's complement form. We have to find its 2's complement like this, right? Now observe. Sir, let me repeat again. The most significant bit is 1. I mean sign bit. 0 means positive number. 1 means negative number. Positive numbers will be represented directly in the memory, sir. If it is a positive number, directly like this. If it is a negative number, then automatically it will be represented in 2's complement form. Okay, how to find 2's complement is, first we have to find 1's complement and then add then we will get 2's complement. But how to find 1's complement, sir? Just interchange zeros and ones. Anyway, it is how you can find. Now my question is, observe carefully. We have to find negation of 5. We have to find negation of 5. First, how to represent 5? This is the very important for me. Can you please tell 5 is positive number or negative number? Hey, please respond. 5 is positive number or negative number? 5. Normal 5, man. Is it a positive number or negative number? Positive number. If it is a positive number, the most significant bit is 0. Correct or not? If it is 0, the most significant bit is 0, because just now I told positive number. 0 means positive number. That's why. Now, first level, how to represent 5? This is about my major target first. How to represent 5? Okay, in the memory, it is a positive number. That's why most significant bit is 0, sir. 0. Okay, well, sign bit I decided, sir. It is the 0. Well, now next one. If it is a positive number, the remaining bits will represent value directly. But it is going to take internally 32-bit representation. That's why 0, 0, 0, 0, and then 0, 0. Sir, 5, right? 1, 1, 0, 1. What about the value of 101? What about value of 101? 101 means 5 only. That's why. So 5 internally at memory level in terms of zeros and ones, how it is going to be represented like this? Yes, ma'am. Up to this, any doubt? Can you please confirm? Up to this, any doubt? At memory level, how the 5 is going to be represented? This is what I did. Up to this, any doubt? Respond, man. Clear, right? In memory, we will have 32-bit representation at memory level for most of the languages. That's why I'm taking 32 bits. In that first bit is the sign bit, and the remaining 31 bits will represent value. 1 bit reserved for sign. Up to this, any doubt? Clear, right? Okay, internally, how the 5 is going to be represented in the memory? Okay, now, so do you know, if I have 5, assume that, sir, I have 5 is there. 5 is represented something like some bits like this, right? Negation of 5 means complement operation I'm asking. Complement operation I'm asking. So complement of you can get very simple, sir. Interchange zeros and ones. If it is a 0, replace with 1. If it is a 1, replace with a 0. Then negation of 5 we are going to get. Okay. Now for this, let me find the negation of 5. I want to find a negation of 5. Negation of 5, how you can get, sir? How you can able to get negation of 5? Very simple, sir. Interchange zeros and ones. Interchange zeros and ones. Sir, here 0 is there. Here 0 is there. Now it will become 1. Here 0 is there. It will become 1. Now here also 0 is there. It will become 1. Sir, 1, 1, 1, 1, 1, 1, 1, 1. And then here 1 is there. It will become 0. Here 0 is there, it will become 1. Here last one is there, it will become 0. That's all. This is the value of negation of 5. Any doubt? Yes, ma'am. What I did, negation of 5 means interchange zeros and ones. I didn't do anything because complement operation you are asking. Hey, can you please perform bitwise complement? Bitwise complement. Bitwise complement means 0 will be replaced with 1, 1 will be replaced with 0. That's all. Itself is nothing but bitwise complement. Any doubt? Up to this is the clear? Okay. Now, sir, whatever value represented by this one, whatever value represented by this combination is the value of negation of 5. Okay. Now my question is, what is the value represented by this combination? How you can find? How you can find? Very simple, sir. What is the most significant bit? Array, respond, man. What is the most significant bit? 1. 1. 1 means is it positive number or negative number? Is it positive number or negative number? Negative number. Negative number. Okay. Oh, boss, most significant bit is 1. That's why it is the negative number. If it is the negative number, the remaining bits won't represent value directly. It will represent in 2's complement form. Regarding it will represent in 2's complement form. Remember that, right? Okay. Now the point is, have a look once. Okay, the remaining bits represent in 2's complement form. Sir, why the remaining bits will represent value in 2's complement form? Because it is the negative number. Correct or not? If it is the negative number, the remaining bits will represent value in 2's complement form. That's why it is going to be there, sir. Remember this one. Now, what is the next thing we have to take? What is the next one we have to take? How to find 2's complement? How you can able to find 2's complement, right? Very simple. How you can able to find 2's complement? Very simple, sir. Here 1 will be replaced. First find 1's complement. First find 1's complement. 0 0 0 0. Now, sir, here 0, and then this 0 will become 1, this 1 will become 0, and then this 0 will become 1. Okay, this is 1's complement. 1's complement. How to find 1's complement, sir? Zeros and ones, like this I'm taking, sir. Now add 1, because how to get 2's complement? First find 1's complement and then add 1. 1 plus 1, 1 plus 1, 0, 1 and a carry. 0 plus 1, 1. Okay, 1, 1, 1, remaining are zeros. 1, 1, 0. What about its value? 6. Sir, already negative. Minus 6 is the answer by default we are going to get. Very simple, sir. Now take a bit special care. Sir, whatever this combination is going to represent, this is the value of negation of 5. Sir, complement of 5. So in that most significant bit is 1, means a negative number. If it is the negative number, remaining bits will represent value in 2's complement form. Remaining bits will represent value in 2's complement form. How to find 2's complement form, sir? First we have to find 1's complement, and then add 1. Automatically 2's complement by default we will get the value represented by the 2's complement itself is nothing but result. Any doubt? Yes. Any doubt? Yeah. Can you please? Some people are asking. If a 5 is negative, wow. If it is a 5 is the negative, then our life will be very horrible. Regarding if a 5 is the negative, then first you have to represent negative value into its complement form, and then we have to apply complement operation. Sushil, yes, it's possible. If it is a negative, then the most significant bit is the 1, and the rest of the bits we have to take into its complement form, not directly. Clear, right? Okay, a bit mathematics level, but make sure with this hint you can able to practice. Okay, R or just a matter of 1 minute? Anyone, can you please tell what is the value of negation of 4? Negation of 4 I am taking. Don't tell any shortcut. Don't tell any shortcut. I want to find negation of 4. Remember this one. So first, how you can represent 4? How you can represent 4? Legend, matter of 1 minute. How you can represent 4? Sir, 4 is the positive number or negative number? Please respond. 4 is the positive number or negative number? Respond, man. 4 is the positive or negative? Yeah, 1 minute. 4 is the positive number or negative number? Positive number, right? Okay. So now it is the positive. It is the positive number. Then the most significant bit is 0. If it is the positive number, the remaining bits will represent value directly. Are you getting right? The remaining bits will represent value directly, sir. Directly. The remaining bits will represent the value directly. Now 0, 0, 0, 0, and so on. 0, 1, 1, sorry, 1, 0, 0. That's all. Sir, any doubt about 4 representation? No doubt at all. This is the most significant bit. This is the most significant bit. The remaining bits will represent value directly. Up to this, not required to keep any explanation. Can I expect like that? How to represent 4? Now my question is, negation of 4 I want to find. Negation of 4 I want to find. What it means is, now can you please apply complement operator for 32 bits, not 1 or 2 bits, for all 32 bits complement operator. 0 will become 1, 0 will become 1, 1, and 1, 1, 1, 1, 1, 1, like 1, 1. Now this 1 will become 0, 0, and this 0 will become 1, this 0 will become 1. Excellent, man. Negation of 4. Any doubt up to this? Just what I'm doing, interchange, complement operation. Zeros replace with ones, ones are replaced with 0. Pass. Any doubt? Any doubt up to this? Now, most of the people are facing the problem now only. Here, what is the value represented by this one? What is the value represented by this one? It is a very important. What is this bit? The first bit is called? Array, the first bit is called? Respond, man. The first bit is called? Sign bit. The most significant bit, sign bit. If the sign bit is 1, means sign bit 1 means positive number or negative number? Means negative number. The sign bit is 1 means negative number. Oh, it is the negative number, man. If it is the negative number, remaining bits represent value in 2's complement form. Remaining bits represent value in 2's complement. 2's complement, right? Okay. Sir, how to find 2's complement? First we have to find find 1's complement, and then add 1, and then add 1. This is the way how you can find 2's complement. But how to find 1's complement? Sir, observe how to find 1's complement. Interchange zeros and ones. That's all. Now here see, if the sign bit is negative, the remaining bits represent value in 2's complement. Now find 2's complement form of these remaining bits. Yes, these are the bits. For these remaining bits, I have to find 2's complement form. First we have to find 1's complement. First we require to find 1's complement first. Are you getting 1's complement? Can you please tell how I can find 1's complement, sir? Interchange zeros and ones. 0, 0, 0, 0, 0, dot, dot. Sir, 0, 0. If it is a 0, it will become 1. Next 1 will become 0. This is 1's complement. Any doubt? Ayo, respond, man. Any doubt about this one? First find 1's complement. After finding 1's complement, for this add 1. Add 1. Can you please add 1 for this? If I add 1 for the 1's complement, then automatically 2's complement by default you will get. Now add 1. 0 plus 1 means 1. 1 and then 0. and then 1 1 1 0 1, and the remaining bits are 0 0 0. Now 1 0 1 1 0 1, what is the result, sir? 1 0 1 means 5 5. It is already negative because of most significant bit. Now the result we are going to get minus 5 is the output we will get. At least now 50 to 70% of the people are getting the concept. Yes, ma'am. Yes, what is the output by default we are going to get? Now negation of, observe that, negation of 4 I'm taking. The output by default we have to get minus 5. Clear, right? Yes, internally memory level, how it is going to be there. That's all. This is about what you people should aware. Nitin Patil, bitwise complement. Sir, it is not Boolean complement. Bitwise complement, there is no guarantee what we are going to get. Yeah, there are some people are asking just the negation of 5. Negation of 5. 5 we are going to get. Regarding Nitin, next one after that, negation of minus 7. Negation of minus 7, 6 we are going to get. Getting? This is what you people should aware. Bitwise operations we are going to get. Memory, how it is going to be stored at minus 5. Are you getting how the memory is going to be stored for minus 5? All these things not required, sir, you can practice. If you are getting, if any one is required, then automatically another half an hour we require to spend. Sir, negation of minus 5, how you can able to represent? Do you want me to explain? The remaining people may beat me. Okay, no, sir, this is just except very rare we are going to use, not required to worry at all. Okay, ignore that. You can able to identify it's a mathematics background. It's a very easy thing only. Just I will provide at least hint. Yes, the people who are expecting negation of minus 5, first thing you require to represent minus 5. Observe that the most significant bit should be 1. But if it is the most significant bit is 1, the remaining bits should not represent value directly. The remaining bits should represent value in 2's complement form. Sir, actually 0 0 0 0 0 0 1 0 1 is the direct. For this, apply 2's complement first. Find 2's complement. So 2's complement 1 1 1 1 1 and so on. 1 1 1 1 1 and so on. Okay, 0 1 0 1's complement. Add for that 1 1 and so on, 0 0 1 1. Okay, you know 0 1 1 like so. Minus 5 internal representation is 1 followed by 2's complement form of 5 means 1 1 1 1 1 and so on, 1 0 1 1. Wonderful, man, boss. This is the representation of minus 5. Once you got minus 5, now negation of minus 5 you can apply. Negation of minus 5 you can apply. Are you getting right? Sir, negation of minus 5 means 0 0 0 0 0 0 0 0 1 0 0 like this. What is the most significant bit? 0. 0 means positive number or negative number? Positive number. Oh, if it is a positive number, happily you can represent value directly. Direct value 100 means 4. So negation of okay, minus 5 is nothing man, plus 4 is the answer we are going to get. Let me cross check. Negation of minus 5 plus 4 is the answer. Are you able to understand? Yes. Who is asking? Just go through just with this hint you can able to practice, then you can get much clarity about that. Don't worry, sir. In real time, in programming world, very rare we are going to use. These are not commonly required. That's why not recommended to spend much time on these areas. If really helpful, yes, meaningful to spend some time. Okay, yes, ignore. Yes, very rare. In general, we never going to use, but logical operators are very commonly we are going to use. Bitwise operators very rare, especially scientific applications, electrical engineering applications, there we are going to use these kind of things. Remember that complex numbers, bitwise operators, all these. If I want to develop some mathematics based application, very rare we are going to use. That's why don't worry much about that. Can I expect everyone got clearly? Yo, Subrat Kumar. Yes, man. Okay. Can I go to the next level? Now listen this one, sir. Very, very simple. What is the next one we have? What is the next one we have? Shift operators. Shift operators. Almost most of the languages already deprecated these operators because of performance issues. That's why most of the people these days never recommended to use these bloody operators, because shift operators are very costly operators internally, because bit by bit all the bits are required to shift either to the right or shift to the left. That's why these things are by default considered as almost deprecated because of performance issues in most of the languages, right? Okay. Now at least Subrat Kumar, now you have to understand. Here say this one. Shift operators, right? Sir, what is the first one? Left shift operators. Left shift operators. It's very easy, right? Left shift operators. Sir, like this. Left shift towards left hand side. Shift towards left hand side. Sir, what it means? 10 left shift 2. 10 left shift 2, sir. Sir, what's my requirement here? Hey, can you please shift the bits of 10 by 2 bits left? Can you please shift 2 bits to the left, 2 bits to the left, like this, right? Now, first question, how you can represent 10? How you can represent 10, sir? 10 internally represented as most significant bit is 0, 0, 0, 0, 0, and dot, 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 0, 0, 1, 0. Sorry, 1, 0, 1, 1. 10, 10, right? 1, 0, 1, 0. Correct or not? 10, 10. 10 means binary. 1, 0, 1, 0. Excellent. Now, I want to shift to left hand side or right hand side? Can you please tell? Left hand side or right hand side? Oh, left. Move to the left. If I move to the left, now this one will be gone. This one will be gone. Correct or not? These 2 bits by default will be gone because 2 positions move to the left. If you move to the 2 positions left, then automatically here 2 cells are vacant. 2 cells are vacant. So these 2 vacant cells always filled with 0. Always filled with 0. Remember this one. Vacant cells always filled with 0. So means after shift operation, what will happen is these 2 zeros by default will be gone. Here 2 spaces are 2 blank cells are going to come. Can you please fill with 0, 0? Are you getting? What is the result of this one? You have to tell. Can you please guide what is the result of this one? What is the most significant bit? Please tell what is the most significant bit. The most significant bit is 0. 0 means what? Positive number. Oh, if it's the positive number, remaining bits directly represent the value. Sir, 2 power 0, 2 power 1, 2 square, 2 power 4, 2 power 5, 2 power 6. So 1 into 2 power 6. Do you know binary to decimal? 2 power 0, 1, 2, 3, 4, 5. Sorry, can you please consider what the answer by default we are going to get? 2 power 0, 2 power 1, 2 square, 2 cube, 2 to the power 4, 2 power 5. So 1 into 2 power 5. 1 into 2 power 5. Okay? Plus 0 into 2 power 4. 1 into 2 power 3. 1 into 2 power 3. All the remaining are zeros only. 2 power 5, 32. Plus 2 power 3, 8. Its value is nothing but some 40 by default we are going to get. Okay, beautiful. Just observe that 40 by default we are going to get. Is it really 40? Really 40? 10 left shift 2. 40 is the answer by default we are going to get. Sir, very simple. Shift 2 cells to the left hand side. Shift 2 cells to the left hand side. And vacant cells which are coming on the right hand side. Can you please fill with 0? Can you please fill with 0? That thing is nothing but left shift operator, right? Are you getting? Don't tell any shortcut techniques. It is not mathematics session. Okay, just memory level how the things are going to be happen, you people should be aware. Similarly, I want to do right shift 2. Anyone can you please tell? 10 right shift 2. 10 right shift 2. I want to do that. I want to do that. How you can able to do, sir? First, how you can represent 10? Most significant bit is 0, sir. 0 0 0 0 0 and then 1 0 1 0 1 0 1 0. Any doubt? Ayo, respond man. Any doubt? Any doubt about this one? Hey, shift operators. Any doubt? Okay, this is the 10 representation, right? Now I want to shift 2 cells to the right hand side. If you want to shift 2 cells to the right hand side, then the last 2 things by default will be gone. Last 2 things by default will be gone. Here 2 vacant cells by default will be formed. These 2 vacant cells should be filled with the sign bit. Remember this one, sir. These vacant cells which are coming on the left hand side should be filled with the sign bit. If it is the positive number, filled with 0. If it is the negative number, filled with the -1. Filled with 1. If it is the positive number, 10 is already positive number. That's why 0 0 by default is going to come. 0 0 0 0 0 and so on. 1 0 positive. 0 means positive. Remaining bits represent value directly. What about 1 0, sir? 2 2 like this, right? Now 10 right shift 2, sir. What the output by default you are going to get a 2. Any doubt? Any doubt? Yeah, there are some applications are there where we are going to use these shift operators, bitwise operators, all these things, man. There are some very specific applications are there. Simple logic. If you are not going to use these operators, why these operators are there in our programming languages? Remember that there are some application areas are there for this, but anyway in our day-to-day programming we may not. Tomorrow, just can you please develop a small calculator? Can you please develop a small calculator? Here plus operator, minus operator, star operator, yes, should provide. Even shift operator also, can you please provide support? Left shift also. Then automatically how you can develop? How you can develop? I don't know about shift operator. Sorry. Your calculator should contain this functionality also. Getting? Yes, correct. Next, and after that, if I want to do some encryption kind of thing, encryption security kind of things, like these operators will play mathematics based applications especially. Okay, we can I go to the next level, sir? Up to this, any doubt? Shift operators, like, sir, total these bitwise operators we discussed, right, sir? Something like mathematics class. Something like mathematics class. Okay, like AND operator, OR operator, XOR operator. Next, and after that, bitwise complement operator. Next, left shift operator, right shift operator we covered already. That's all. These are the things. These things are nothing but bitwise operators, right? Next, and after that, we can apply these bitwise operators for Boolean types also. Just now I covered. You can apply for int type. You can apply for Boolean. We applied already for int type. For Boolean types, how the behavior, right? For Boolean types, how the behavior will be there? Very simple, sir. For Boolean types, how the behavior will be there, sir? So here, true and false. True and false. Normal, you know, right? When AND operator returns a true, if both are true, then only result is true, sir. But here, true and false, then obviously what answer by default we are going to get, sir? True and false. Can you spell out what the answer we are going to get now? False is the answer. Next, true or false. What the answer by default we are going to get? True itself is the answer. True itself. Next, true X or false. True X or false. Sir, both are different. That's why true is the answer. Any doubt? Any doubt? True and false? True or false? True X or false? Same. Already we know. Just normal. If both are true, then only result is true in AND. At least one true, then the result is true. If both are different, then only the result is true. Excellent, man. Listen this one. Don't get shocked. Negation of true. What the answer? Immediately you have to tell why you are thinking this much. Immediately you have to tell why you are thinking this much. Negation of true. Negation of true. What the answer we are going to get? Negation of true. What the answer we are going to get? 100% pakka. The answer by default we are going to get -2. Remember, it's not false. It's not false. If it is not true, if it is not true, it is the false, sir. If it is not true, it is the false. But here, bitwise, if you can apply bitwise complement operator for Boolean, in Java it is the compile time method. But here, what will happen is, it is internally treated as negation of 1. Negation of 1. Now the total story we require to apply, then automatically -2 we are going to get, sir. Now, legend this one, true, and false. False is the answer. Next, true or false. True is the answer. True XR false. True XR false. Then automatically true is the answer. Okay, well. Next, negation of true. Negation of true, sir. -2 is the answer. -2 is the answer. So negation of true means 1. Negation of true means 1. Negation of 1. Apply again the same story. Again the same story. It's the positive number. It's the positive number. If the positive number means first significant bit is 0, 0, 0, 0, 0, 0, 0, and so on. Its value is 1. Its value is 1. Apply its value is 1. Apply negation. Then automatically it will become 1, 1, 1, 1, 1, 1. At last 0 will be there. Most significant bit is 1. If it is the 1, apply. If it is the 1, apply 2's complement form. 2's complement form for this one is 0, 0, 0, 0, 0, 0, 0, 1. Add 1 for that to get 2's complement. 1 plus 1, 0, 1, and so on, dot. It's already 1 negative and 0, 0, 0, 1, 0 means 2. -2 is the answer. You can think a bit carefully, then obviously -2 by default you are going to get. Don't worry much about that. Okay, next last one, sir. True left shift 2. Anyone, can you please guess the answer? True left shift 2. Anyone, can you please guess the answer? Respond, man. True left shift 2. Very simple. 1 left shift 2. 1 left shift 2. How you can represent 1, sir? 0, 0, 0, 0, 1, sir. 0, 0, 0, 0, 1. I want to shift 2 cells to the left. If you shift 2 cells to the left, 2 vacant cells by default will be there. 0, 0, we have to add. Sir, 1, 0, 0 means what? 4. That's why true left shift 2, sir. 4 is the answer. 4 is the answer. Can you please tell true right shift 2? What is the answer? True right shift 2. What is the answer? True means 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, sir. 1. Well, 2 cells we have to move to the right hand side. Then this 0, 1 by default will be gone. Vacant cells filled with the sign bit. Sign bit is the 0 only. All are zeros. Then automatically the answer by default 0 is the answer. Any doubt? Okay, but anyway, very rare we are going to use this, but having just a few minutes discussion is highly recommended, right? That's all. Just today I'm stopping this mathematics session. Tomorrow we will discuss about Python session.